Hey, this is Leach with Simpson Math, and in this video, I'm going to be talking to my contemporary students. We're talking about 2.2 in our text, which is dealing with subsets, specifically about the how many elements or how many subsets there are in a set. So let's take a look at this first one. So first it says find, this is number 13 on your 2.2 homework. Find the number of subsets, and then we'll find the number of proper subsets of a set. And the set they're wanting us to look at is the set of days of the week. So that's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, which is those 7 elements. Before we deal with the 7 elements, let's just look at a smaller group, and let's take a look at this one. So I have here, just looking at the first 3, Monday, Tuesday, Wednesday, how many sets could be made of Monday, Tuesday, Wednesday? So maybe thinking of, you have something to do. You can do it. You might not do it at all. You might do it every day. You have Monday, Tuesday, or Wednesday to work on it. So when are you going to work on it? Well, you could work on it every day, Monday, Tuesday, Wednesday, all the way down to working on it never. And we can visualize this with the tree diagram. So on Monday, you could maybe work on Monday or you don't. I just crossed out Monday to represent that I'm not working or not doing Monday. So Monday could be included in the set or Monday's not included in the set. Either way, Mondays either happen or it's either in the set or it's not. Then looking at Tuesday, Tuesday could be in the set or it's not. Notice, so if Monday didn't happen, Tuesday has the same kind of options. We're not worrying about probability, like whether it's likely to happen or not, but just those are my options. It could or it couldn't. Notice this is a binary situation. Monday's in the set or it's not. Tuesday's in the set or it's not. Wednesday's in the set or it's not. So looking here, I've kind of summarized the results of each of these. So Monday, Tuesday, Wednesday are all in the set. So the set would be the set of those 3 days, Monday, Tuesday, Wednesday. The second one, Monday, Tuesday is in the set, but not Wednesday. So the set is just Monday and Tuesday. So we can follow each of those paths all the way down, and notice we get 8 total sets. If I would have just stopped at 2, I would have had 4 total sets, 4 total possible subsets, I should say. If I would have stopped at just Monday, notice I could have had just 2 possible subsets. Either it happens or it doesn't. So notice that what's happening with that math here. So it is, like I said, it's binary. So it either is or it isn't. It happens or it's not. So this is kind of a base 2 situation. So notice we have 2 possible outcomes, 2 possible results for the Monday. So that's 2 to the first. Why am I picking this 2? Because there's 2 outcomes. It happens or it doesn't. And I only have 1 element here that I'm dealing with. Here with Monday, Tuesday, I have 2 elements. Each of those could either happen or they don't. Oops, this is a typo. This should be a 4. Then for this one, I have 3 elements, Monday, Tuesday, Wednesday. Each of them either happen or don't. And so we can do that with exponents. 2 to the third is 8. So to go to the question that they're asking about, the question says, what about the set of the days of the week? Well, there are 7 days of the week. So that would be 2 to the 7th, or 128. Let's pause for a second and talk about how I got to that 128. We can use our Desmos calculator. So you can, in my course, you can use a physical calculator if you have it, so physical, scientific, or graphing calculator. But I'm going to encourage you, if you don't have specifically a graphing calculator, not that you need the graphing utilities, it's just later we'll be doing some stats, and you want to have friends with that. You want to be able to calculate that has that. So we'll just use Desmos for a lot of our math things. So I want to do 2 to the 7th. So I can just, if I'm on a real computer, which when you're doing your test, you can use Desmos and you'll be needing to use it on a real computer. So I'm just going to type in 2 on my keyboard. And then to get to the exponent, I'm press Shift 6 to get my cursor up into the exponent, and then 7. If you look on your keyboard, 6 has the little caret on it. So that's how we can type it into Desmos without using the on-screen keyboard. If you want to use the on-screen keyboard, bottom left corner, you can open up the on-screen keyboard. You can type in 2 on here, or or use the keyboard. And here's where you can get the exponent. So 2 to the second. If you type 2, if you do the a to the second, it'll give you the square. I don't want that. I want 2 to the whatever I want it to be. So I'm going to press this a to the b. So it's the same thing as just Shift 6. So then to the 7th, and I get my 128. So there's my answer there. All right, so that's how we get that 128. Let me put that in. 128. Well done, it says. All right, now it wants the number of proper subsets. So let's go back to the notes, to my scratch work. So the Oh, my brain broke. I wrote this incorrectly. It's not about the empty set. It's about this, since my brain was thinking of the question that we'll do next, 17 and 18. So here, the proper subset, the issue with the proper subset is this one, this Monday, Tuesday, Wednesday. I want the number of proper subsets, so I don't want all of them. I want everything but that one. So I'm going to not include this top one. So notice here, this empty subset is included. The empty set is included. So no set would be 1, 2, 3, 4, 5, 6, 7. Or since we already counted up that there was 8, I'm just eliminating 1. If this 1 was not here, then those are all my these are all proper subsets. This one is not. So that's why I can just do 2 to the 7th minus 1 to get my 127. Or generically, let me kind of leave that zoomed out. Or generically, if you let n just be the number of elements in a set, so in this case n would be 7. The number of subsets is 2 to the 7th, or 2 to the nth, or in this case 2 to the 7th. The number of proper subsets is 2 to the n, and then you do a minus 1. All right, let's take a look at number 17 and 18. They're friends. Oh, I didn't answer the question. Let me do that. 127. Check. Yay. Now it's happy for me. All right, let's move on to 17. All right, so this answer will be a bit big. It'll be in the millions. Don't stress. So this says the 24 members of the mathematics club must send a delegation to a meeting for student groups at their school. So there's 24 members in the math club. Remember the pro tip, if you highlight and you see something that doesn't highlight, that's what randomizes if you get a new question. So so this number changes. So they're going to send a delegation to a meeting at their school. The delegation could include as many members of the club as desired, but at least one member must attend. So all 24 could go, all the way down to one person could go. So let me put back up this diagram we just had a second ago. So on here, it's a very basically kind of similar idea as the number of subsets compared to the number of proper subsets. The number of subsets is 2 to the n with the number of elements that we have. But here, 2 to the nth. But it says at least one member must attend. Since at least one member must attend, well, if there were 3 members of the math club named Monday, Tuesday, Wednesday, just go with it, all 3 could attend, down to only just one attending, just Monday or just Tuesday or just Wednesday. This one situation would be the one that makes that the school would be upset because someone from the math club didn't go. And so notice there's 7 of those possibilities. It's the same logic here. There's just one that didn't make it happy. So we do 2 to the nth to get my total, then minus 1 overall to be able to minus 1 overall to remove that empty set. So let's do that math. I'm going to pop open Desmos. So it says there's 24 members of the math club. Okay, so that's 2 times 2 times 2 times 2 times 2, 24 total 2s. So I'm going to do 2 to the 24. And that does get pretty big. Like I said, it's going to be in the millions. That's 16,777,216. But this is the total number of subsets. I want the total number of subsets that doesn't count the empty set. So I'm just going to do a minus 1. And so instead of it ending in 216, it ends in 215. So 16,777, 215, 16,777, 215. Huzzah. I am curious if it would, if I don't need the commas, surely I won't need the commas. Oh well. Okay, the next question, that was 17. Let's do 18. Bye, puppy. Bye, husband. The puppy's name is Marty. Okay, so now this is a very, very, very similar question. The randomization does happen a little bit here. So pretend it was 24 again, but it's 21. So the 21 members of the math club ascend a delegation, include as many members as desired, but it must be -1. Cool. So that's the same thing we just did. We just have a slightly different number here. But look at this part. Suppose 9 members say they do not want to be part of the delegation. They're like, don't pick me, I'm busy, or I'm in this other club. So 9 members already say that they don't want to go. So how many different delegations are possible? Well, basically, we don't worry about if, in order sorry, I'm rambling. 21 total members, 9 say they don't want to go. Well, how many members could go? Well, let me open up Desmos again. You find that. So how many could go? So if I did 21 minus the 9 who don't want to go, that's 12. So I only have 12 possible people who are ready and willing to go. So how many substitutes could be made of those 12? Well, that's 2 to the 12th, or 4,096. But I don't want, we can't not send anybody. So I'm going to get rid of that one possibility where one person won't go. So that's how I'm going to end up with 4,095. Let me say that again. So we had 21 members who are 21 people in the club. 9 are like, I'm not going for one reason or the other. So that leaves 12. So we have 12 total people who are wanting, willing to go, interested in going. How many different ways could we send people to this thing? What is it? They're going to a group. They're going to a meeting. So how many different ways could we send the people to the meeting? If we were allowed to send nobody, there'd be 4,096. But ignoring the one way that it would be sending nobody would be subtracting 1. We get 4,095. 4095. Good job, us. All right. So I hope. Oh, this one I forgot. Do I have this on my list? Oh, I'll do this one next. So catch me in the next one. I'm going to do 19 and 20. I saw it. I was like, I want to do that one. Yeah. Well, I'll do that in the next video. All right. Check you later. Bye.